Today we want to look at coordinate systems and projections. This is course code CIS GIS 005. Coordinate system and projections is very important in ArcGIS. For us to locate a particular locations in ArcGIS work, you need to understand how coordinate system and projection actually work. We are living on a spherical earth, and location of any feature can be determined using a coordinate system. So most of the latitude and longitude we use are in 3D coordinate system. So most of the time, these 3Ds are actually projected into 2D dimensions for us to actually use them in metric system. So that's why we need to understand how this works in ArcGIS environment. Then we need to look at different, the way we are going to work, how we're going to work with different coordinate systems and projections. In these models, we'll be looking at all this, the geographic coordinate system, which is GCS, and map projections. We'll look at projections and distortion concepts of the datum, projection parameters, and also working with GCS, projection on the fly, defining coordinate system and datums, applying and defining projection on the fly, and also projections of GCS into UTM zones, then georeferencing and GIS approach. Then 8 will be looking at raster projection, setting our environment, and rectification of raster and datum conflicts. So this is what we are going to treat in this model. Then looking at this model, as we just said, that the Earth is actually spherical in nature, and any point on Earth can be determined using coordinate systems. So these are some of the points we need to note. The latitude and longitude we actually use in coordinate system are spherical or ellipsoidal. So the system describes the location of features on Earth. So any particular point we are working on Earth has a number, a particular number or figure, which is known as coordinate, assigned to it. Without that, we won't be able to know a location or a georeference location. So another thing is looking at the projections. When we say projected, that the coordinate is projected, it means that the coordinate is transformed from a 3D format to a 2D format in a planar format so that it could be read and be used. So projected or plane coordinate is another system which involves the projection of sphere from a 3D view into a 2D plane view. Another one is that the latitude and the longitude coordinate can be converted directly into different plane coordinates. So the conversion from one coordinate to another is extremely important in working with ArcGIS. This is actually what we call projection. So conversion from one place to another coordinate into a plane coordinate is what we call reprojection. So you can project a coordinate into a particular plane coordinate. Then from there, you can reproject it into another coordinate. Depends on the kind of model or the location you are working on. So the ArcGIS actually understands this because a lot of mathematical formula and formations have actually been built into this software to accommodate and handle projections and coordinate conversions. So we need to understand how this works for you to actually go on. So you can look at the Earth, you can see this is actually the way the shape of the Earth is. It can be prolate. So most of the time, the Earth is regarded in this format or in this format. So looking at the GCS system, which is used to locate and measure the location of any feature on the Earth's surface in terms of its latitude and longitude, and it is based on 3D sphere. So you can look at this, the latitude actually measures the coordinate from the north to south, while the longitude measured east to west. So depending on actually where you actually working, it is also further divided into quadrants. Latitude and longitude can measure either degrees, minute and second, or decimal degrees. So 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. So this is actually how it works. So the Earth is divided into into different types of lines, the meridians and the parallel. You know, the actual lines, the meridians, this is the equator. You know, the prime meridian is running straight from the North Pole to South Pole and passes through the Greenwich in England. So the rest of the meridians are moving away from the prime meridian and are spaced further apart on the equator. You know, as it converges to a single point at the north and south poles. The latitude are lines of parallels and run from east to west. You know, so why and measure the location in the north and south direction. Parallels are equally spaced between the equator and poles and always parallel to one another. So any two parallels are always the same distance apart all the way around the globe. So parallels and meridians are cross one another at right angles, 90 degrees. The longitude ranges from 0 degrees to 180 degrees and 0 degrees to minus 180 degrees in the west. Why that of latitude ranges from 0 degrees to 90 degrees north and 0 degrees to minus 90 degrees south. So the Earth, when you're talking about the Earth, the east to north orientation is positive, while the west and south orientation is negative. We are in the north and the east, which means most of our coordinates in Nigeria falls within the positive zones. So the latitude, longitude is used the same way the XY coordinate is used in any plane coordinate. So it is used as a reference grid to find locations of features. Now the origin of GSS is the point where the prime meridian intersects the equator. Latitude and longitude can also be measured either in degrees, minutes, as I've just said before, you know, degree, minutes, or in decimals. So this is the concept of geographic coordinate system. Then looking at the projection, map projection, what is the essence of map projection? You know, having understood that the Earth is spherical and most of the time we want to project this from a 3D dimension into a 2D dimension. So when we're talking about map projection, it is basically mathematical formulas whereby we use those formulas to transform the 3D Earth into a 2D or into a planar surface. It's a system that represents a graticals of lines of latitude and longitude on a flat sheet of paper. As you can see here, you can see the cartographers actually use this widely in information system, remote sensing, and GIS also. So you can look at the 4 quadrants here. This is the 4 quadrant, the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. The axis of a two-dimensional Cartesian system. You can see these planes are into 4. So they are of actually numbered from 1 to 4, which is Roman numeral. So where the first one, you can see the first one falls within the positive. When the second one falls within the minus and the plus. While the third one falls within the negative. So if you are working within this part of the Earth, definitely your coordinates must be minus. Then if you are here, it must be plus and minus. So this is very important for you to be able to work with every kind of coordinate system. So you should understand where you are working. It's whether in the west or in the east and north and south. So during transformation, the angular geographic coordinates with the latitude and longitude reference position of the Earth are converted into the Cartesian coordinate of X and Y. That means we see our map being presented on a very flat surface. So that is what map projection is all about. So the importance of map projection cannot be overemphasized.